Good morning to all. Myself Vinod Kumar, Assistant Professor, Department of Civil Engineering, um, Rohini College of Engineering and Technology. Today we are going to learn a topic about square column footing. Let's see a problem. Design isolated footing of uniform thickness for RCC bearing a vertical load 600 kN and having a box size of 500 mm into 600 mm, 500 mm. The safe bearing capacity of soil is taken as 120 kN per meter square. Use M20 and a Fe 415. So size of the column is given data. Size of the column is 500 into 500 mm, and the weight of column is that is load is equal to 600 kN, and then SBC is equal to 120 kN per meter square, and Fy is to 415 Newton per mm square, and FCK is 20 Newton per mm square. And first step is to calculate the size of footing. The size of footing is W is equal to 600, and take self weight of the footing is take 10% of the given load. So 10% means 600 into 10 by 100, that is 60 kilonewton. The total load is given load plus self weight of the footing, that is 600 plus 60, that is 660 kilonewton. And then calculate the area of footing. Area of footing formula is load by SBC. So load is 660 by SBC is 120. The value is area of footing is 5.5 mm square. So area of footing is a square footing. So square root of 5.5 square is 2.35. So the area of footing is 2.35 into 2.35 meter. And then calculate the net upward pressure. Net upward pressure formula is load by width into area of footing. So the given load is 600 by 5.5, that is 109.01 kN per meter square. And check the depth on basis of bending compression. The formula is M is equal to P naught by 8 into B by small b into capital B by 4. So the net upper pressure value is 109.01 by 8. The capital B is 2.35 and small b is 0.5 into 2.35 minus 0.5 by 4. The value is 56.08 kN meter. The factor movement is the multiply the value with the 1.5, will get the factor movement, that is 84.12 kN meter. And the check for mu limit. This formula is taken from the code book IS 456 2000. Mu is equal to 2.76 BD square. While comparing the mu limit and mu, we will get the depth. Depth is equal to 115 mm. And the capital D is equal to small d plus effective cover, that is 115 plus 60 is equal to 175 mm. And check depth on basics of two-way shear. In square footing, the two-way shear will occur. So take the percentage of steel reinforcement is equal to 0.3 percentage. From IS 456 page number 73, we will go through the code book and get the tau c value. So tau c value is equal to 0.38, and permissible stress value is taken from tau c into k. So for k value is taken from the code book. For overall depth 175 mm, the k value is 1.25, and tau e is equal to 0.38 into 1.25, that is tau e is equal to 0.475 Newton per mm square. Then for square footing, the critical section is lies from the face of the footing. So A is equal to B by 2 minus small b by 2, that is A is equal to 425 mm square. And check shear VU is equal to 1.5 into P naught into A, that is VU is equal to 1.5 into 109 into 0.925, that is 151.36 Newton per meter square. And check tau is equal to VU by BD, that the value is by substituting the value we will get the D value, that is 320 mm. And check on basis of two-way shear. The two-way shear is occur at the face of the all around the column, that is D by 2 plus D by 2 plus B. the D value is 320 mm and B naught is 820 mm. And check for shear. For shear is equal to P naught into B square minus B naught square. While substituting the value, we will get the shear force at F is equal to 530. We want to know the ultimate shear, so the values multiplied by 1.5, we will get the ultimate shear, that is 795 kilonewton. And then check the shear stress. Shear stress formula is tau is equal to Fu by 4 into B naught into D. Uh, the values Fu is equal to 795 in 10 power 3 by 4 into B naught value is 820 into 320. The value is 0.75 Newton per mm square. And then permissible shear stress is tau is equal to Ks in tau c. While substituting the value, we will get the tau v value, that is 1. While substituting k is equal to 0.5 plus 1, that is 1.5, take k's value is 1. Whatever is greater, we will take the values 1. So tau c is equal to 0.25 into square root of fck, that is 0.25 into 20 square root of 20, that is tau c is 1.118. And then comparing ks tau c and tau v, which is here tau is less than ks tau c, hence it is safe. And then check for design of reinforcement. So then reinforcement formula is m is equal to 0.87 fy ast d into 1 minus fck fy ast by bd fck. While substituting the above formula in the above equation, we will get the ast value. So ast value is 745 mm square. Let us provide 7 numbers of 12 mm bars at 150 mm spacing at center to center distance. And then check for development length. The development length formula is 47 into dia, so 47 into 12 mm, the value is 564 mm. And then length of bar is 1 by 2 into b minus bc. The value is 1 by 2 into 2350 minus 5 into minus 6, that is 865 mm. So L naught is greater than LD, hence it is safe against development length. Thank you.